All right, guys, we are going to be going over our study guide together. So we are doing rigid transformations and congruence. Okay, so number one, it says select all of the true statements. Okay, so we're going to read each one bit by bit and then decide if it is true or not. So A says two squares with the same side lengths are always congruent. Remember, when we see squares, that means that every angle is a 90-degree angle, and if all of the side lengths are congruent, that means that there is only one kind. So, yes. Okay, two squares with the same side lengths are always congruent. Letter B says two rectangles with the same side lengths are always congruent. Okay, same thing. A rectangle is always going to have 90-degree angles in all four corners. Okay, and if they have the same side lengths, okay, it could even be like this setup, right? Where these longer sides are going to be congruent with those shorter sides, or sorry, with these long sides over here, and then the shorter sides are also going to be congruent, okay? Which it looks like it could just be a rigid transformation, a rotation, and a translation. So that could, they're always going to be congruent, two rectangles, okay? The key with these two is that rectangles and squares are always going to have 90-degree angles for all four angles. Okay, letter C says two rhombuses with the same side lengths are always congruent. Remember that a rhombus is a parallelogram with side lengths that are all the same. So it kind of could look like a diamond like this. Okay, could look like a diamond like this. A square is also a rhombus because all of the side lengths are the same. But for a rhombus, the angles could be different. These two angles will need to be the same though, and then these two angles will need to be the same. Okay, so because these rhombuses, there's all sorts of different angles that these two angles could be, or that these two angles could be. They are not always going to be congruent because we don't have exact angle measures. So that one's out of the picture. Okay. Letter D says two parallelograms with the same side lengths are always congruent. Same thing here. A parallelogram is very similar to a rhombus. Okay, you've got two sets of parallel lines. Now we don't know with a parallelogram. I know that these side lengths need to be the same. These side lengths need to also be the same. Opposite angles are going to be congruent, but it doesn't tell us specifics about what the angles are going to be, what the side lengths are going to be. So this one, we don't know that two parallelograms with the same side lengths are always going to be congruent because of those angle measures. Okay. Lastly, two quadrilaterals with the same side lengths are always congruent. Same thing here. We don't know the angle measures of these, so we can't say that these are going to be congruent. Okay? So number two. Number two says lines CE and AD intersect at B. Okay? So we've got two intersecting lines. It says to select all of the true statements. All right. The measure of CBA, that's that 37-degree angle, is equal to the measure of DBE. That's this angle right here, DBE. Okay? I know that that's true because they are vertical angles. Okay? Letter B, the sum of the measures of angles CBA and DBE is 180 degrees. CBA and DBE equal to 180 degrees. 37 plus 37 does not equal 180 degrees. So that is false. Letter C, the measure of angle CBD, that's this angle right here, and is equal to the measure of ABE. ABE is right here. Same thing, that is true because they are vertical angles, okay? I'm going to make a little note here. Vertical angles are equal, so that goes for A and C, okay? Letter D, the sum of the measures of angles CBD and CBA is 180 degrees. Let's look at those. CBD, that's this one right here, and CBA is right here. I know that those are equal to 180 degrees because the two make up a straight line. So that's true. Okay. And the last one, the sum of the measures of angles CBA and DBE is 90 degrees. CBA and DBE is 90 degrees again. 37 plus 37 does not equal 90. So that's going to be false. All right. Number 3 on the back side says, Diego made a shape on the left and Elena made a shape on the right. I'm just going to label those D and E for reference. Okay, select all the true statements once again. Letter A, the smallest circle in Diego's design is congruent to the smallest circle in Elena's design. Okay, this small guy right here and this little small guy over here. They are congruent because they are circles and they both have a diameter of 2. So that's going to be true. Letter B, Diegol's design is congruent to Elena's design. The designs themselves are not congruent. Okay, and I can just tell that because they're different designs. Letter C, Elena's design is a translation of Diego's design. Okay, there is no translation, rotation. There's no rigid transformation that I could do to make this circle, this design, go to this design. So it's going to be false. D, the largest circle in Elena's design is congruent to the largest circle in Diego's design. The largest circle has a diameter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And Diego's diameter is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are going to be congruent because they have the same diameter. And E, each circle in the Elena's design has a congruent circle with Diego's design. This is going to be true because when I look at each of the small circles, we already know that the smaller circles are congruent because they have the same diameter. Okay, the second smallest has a diameter of 1, 2, 3, 4. 1, 2, 3, 4 units. Same thing over here, 1, 2, 3, 4 units. Okay, and when you count up all of the diameters of each of the circles, they do have corresponding circles. So that is going to be true. A, D, and E. All right. Number 4 says to describe a sequence of transformations that shows a polygon A, that shows that polygon A is congruent to polygon B. Okay, so when I take this, so it already tells me that they're congruent. So what I can do, and I'm going to take some patty paper, brought it home with me just in case. So I'm going to trace over A. Okay, with that patty paper. I'm going to see how we can get it over to B. Okay, how can we get it over to B? So first thing I'm going to do is I'm going to rotate this 90 degrees counterclockwise. Okay, so now and around this point, 90 degrees counterclockwise around the rightmost point right there, that little corner right there. Okay, rotate it 90 degrees. Now it looks like it's just a translation, and I'm just going to translate it 1, 2, 3, 4 spaces. Okay, so off to the side here, I'm just going to write this is a rotation 90 degrees counterclockwise. around, and I'm going to label this point C, around point C. Then translate to the right 4 units. Awesome. Okay, so there's that. Okay, number 5. I'm going to skip number 5 for you for the sake of online learning because I know that you guys will know how to tell if these two are congruent, but for the sake of this, using patty paper and trying to see on the computer screen, I've kept that off the test for you. Okay, and number 6. Ooh, number 6 up here. Okay, lines A, B, and C, D are parallel. And then find the measures of the 3 angles in triangle ABF. So this triangle right here is what we're going to look for. Okay, I need 1, 2, 3. Okay, so let's look for, so for this one, all I really need to do is look at what I know. I know that this angle right here at point C is 42 degrees. I know that this angle right here at D is 157. Okay, so I'm kind of going to just play around and look for angles that I know for sure. Okay, so this angle, I know that is 157. Therefore, I know this angle is also 157 because they are vertical angles. Okay, now remember the alternate interior angles. Alternate meaning on the opposite side of the transversal, this line that goes all the way up right through here. Opposite side and alternate interior, meaning that they're on the inside of these 2 parallel lines. I know that this angle right here is also 157 degrees. Okay. Knowing that these 2 angles make up 180 degrees. So 180 minus 157, let me pull out my calculator. 180 minus 157 is 23. So I know that this angle right here is 23 degrees. Angle A, 23 degrees. Okay. Let's now look at angle C. So angle C up here, it tells us that this is 42 degrees. Again, alternate interior angles, meaning other side of the transversal, still inside. That's that angle right there. And that angle is another angle that I needed to find, which is 42 degrees. So I know that angle B is 42 degrees. Okay. Last one I'm looking for is angle F. Now, because I know that these 3 angles make up a triangle, knowing that a triangle is 180 degrees, okay, I can take 180 degrees, which equals angle F plus 23 plus 42. And of course, solving that equation. So I'm going to show you my work over here. Sorry for the glare. 23 plus 42, which is 65. So I know that angle F plus 65 is going to equal 180. Okay, subtract 65 from both sides, and angle F is going to be 180 minus 65 is 115. Okay, so over here, angle F is 115 degrees. All right. Now, for the sake of time, I've already written out number 7, my answers, okay? It says that triangle CDA is the image of triangle ABC. Okay, so ABC, this triangle here in the middle, is my original, okay? CDA, this triangle right here, is a image after a 180-degree rotation around this midpoint right here, okay? Remember when I do 180 degrees? That creates this triangle here. Same thing. This triangle here is an image after I rotate it around this midpoint 180 degrees. So explain why ABCD and ABEC are parallelograms. So that's this parallelogram here and this parallelogram here, okay? So a 180-degree rotation around any point that's not on the line creates an image that is parallel to the original line. So therefore, AD, that's this line segment right here, is going to be parallel to BC, that's this one right here, and CD, this line right here, is going to be parallel to AB. So therefore, they're going to be parallelograms. Same reasoning, that proves that AB, this line segment, is going to be parallel to CE, and line segment AC is going to be parallel to EB. Okay? And this should say B, not A. B says identify two pairs of congruent angles. Okay? So since corresponding angles and congruent figures have the same measure, I know that angle CAB, so this angle right here, is congruent to ACD, ACD. So this angle right here. This angle here and this angle here are congruent, and BEC. So BEC. So this angle here, this angle here, and this angle here. And then I gave another one just in case. I also know that ACB, so this little acute angle here, is congruent to CBE, CBE, which is right here, and DAC, which is right here. Okay, so I'll let you pause the video in case you'd like to copy those down. If you have any questions, let me know. Of course, come to the office hours 9 to 10 every single day, and I'll be able to answer any questions that you